Hi, I'm Wally from BLACKDOT ENERGY, and today we're visiting a commercial installation to show the benefits of solar PV, in other words, solar electrical power generation, and the elements and facets that needs to be considered for that. This specific project, Henning Holm from Holm and Friends was involved with the design and the specification of the system, and Etienne from EVB Electrical was the installation contractor that installed the project. I'm going to ask Henning to give us a bit of background on the project and what was considered with the design of this plant, and then ask Etienne to give us a bit of an indication of what was involved in the commercial layout and the turnkey solution to get this plant operational. Henning, tell us a bit more about the plant.
Thank you, Wally. Yes, we've got a plant standing in Marble Hall, Limpopo province, a very hot region, in fact, on a SPAR retailer. The first thing is obviously to analyze again the electricity consumption and the specific profile. Now, with these typical retailers, they've got bakeries, so they've got a very early high peak on startup on the ovens. They've got a lot of lighting, which is very important for them to create their sales, so they're very sensitive about it. And they've got big, large roof surface areas, which obviously have high losses and or gains then on energy. So the very first thing was to look at those, look at the insulation, look at the lighting, which FAB Electrical did, and they had to work at night because obviously daytime you can't run around with a ladder from a safety and health perspective, and also so that the consumer or the client is not interrupted in the spa itself. Once that was done, there was quite a long process to get the municipality, the client, the financing in place, because obviously you have to prove that these systems are viable. That is the core of it. And this system turned out to be just about 200 kilowatt, with a peak consumption on this side of about 500 kilowatts. So it's supporting the electricity as we go along. And one of the constraints is roof area. It's a high consumer, intensive consumer, and you've got limited roof space. And you'll see this particular roof is orientating a little bit to the east. North is in fact in front of us, and the panels are installed flat. There's a reason for that, and this is that we couldn't allow for the negative load, wind load that you would have if you stand up the panels away from the roof. The roof is existing, we can't work on it. The structure is really too difficult to work from underneath, and so we had to go with this. In addition, we didn't put a subframe, so the frame system or the clamping system is directly connected to the roof, which brings the total load to below 18 kilograms a square meter. And for the same reason, you see these large 320 72 cell panels out here. Makes the installation quicker. They are a bit more difficult to handle, and we'll talk about that just now. But then in essence, it's a grid tie system which supplies electricity as electricity is produced from the sun. Talking about which, I'd like to ask Etienne a few questions on the installation. Etienne, it took a while to get the design of this particular site done, specifically in terms of the financials, because they were very meticulous about this. Tell us a bit more about the installation. Did it take long? Was it complicated?
Henning, thank you. It was actually not complicated at all. The frames that we used is a galvanized frame which clips onto the corrugated sink we have here. It does not penetrate the roof at all, which is good for leakages, water, and for raining and so forth. The plant took us about a month to install from beginning till we started up. One of the biggest things that we struggled with was to get all the panels on top of the roof. It's quite high. I don't know if you can see from there, but it's high. It's about 12 meters up to the roof. So that was quite a difficult thing to do. And then what was difficult as well as where we brought the panels up was exactly where they received their deliveries. So that was a bit difficult.
Etienne, from a client's perspective, They obviously, you managed this very well in the collection and deliveries of the system. Were they sensitive in terms of time and how you installed, and happy with the result?
Henning, thank you. Yeah, like you said, the lighting inside the shop itself, that was very difficult to do. On top here, we could work whenever we wanted to work, so that was not a difficult thing to do. But like I say, the receiving and bringing up of all the materials, panels and inverters, that was quite a difficult hurdle to get over. But otherwise, the panels, the installation went very well. We did it very quick.
Speaking of hurdles, Etienne, one of the things that we always know is we need to connect the system, as it is a grid-type system, in this case to the municipal network. How did the municipality in Marble Hall react?
Yeah, very good. We actually have a good communication with the head of electricity in Marble Hall. He was very helpful in installing the metering system. Again, so that we can export and import power. So if we have any power available or surplus power, that will be pushed back into the grid, and that will be counted as a credit. In this instance, we don't actually do it because the consumer is from 7 till 7 at night, 7 in the morning till 7 at night. So we don't really have additional excess, but yeah, it was very quick and easy.
We consume literally all the energy as it is generated, and there are three portions of the electricity count. There are these basic fees, which the municipality obviously still claims. Then there's energy, and in addition there's peak demand. Did you see any difference on the peak demand here?
No, we saw a very big difference in the kilowatt hour consumption, but in the peak demand we saw a difference, but not a very big difference regarding the previous months. That was because the biggest loads is in the morning very early before the sun has come up, so the plant can't really help in that time.
So design is important to make sure that the viability that you initially show is also proven later by the generation to be sensitive to the profile of consumption that you need before. This was one of 3 phases that possibly would happen here, and the second 2 phases really depend on viability and the happiness of a client. What is the perspective?
Well, that we have already spoken to the client about. They very happy so far. The idea is to let this plant run for a year or 2, and in that time they would have saved enough money and saw the viability of the plant. Then we would probably go to phase 2 and phase 3 later on.
Just a bit about the plant. In terms of installation, we mentioned that these are large-scale panels, and they had to be specifically very light in the construction. How did you find the complexity or the ease of installing this plant, and did you have any trouble doing this?
No, like I said earlier, it was actually a very easy plant to install. The frames that we use literally just clip onto the corrugated steel or zinc, and it was a very easy, very quick installation. Like I said, it's a 200 kilowatt, and it took us about between 2 weeks and 3 weeks for the physical installation. We took a month here to actually switch on the plant, but the installation went very quick.
Well, thank you, Etienne, and congratulations on a great plant. Wally, there we go. You know, good planning, good integration of all the parties, and a proper system within the legislation framework that is available. It does make sense in South Africa, and here's another good example of that.
Yes, Etienne, well done. Hats off. I think we need these pilot projects and to illustrate to the municipality and to commercial users the benefits. Although solar PV is becoming the norm in commercial businesses and the industry is booming at the moment, it's awesome to see these type of plants. I'm going to ask Henning to give us a bit of a rundown on the inverters and the installation into the grid, so that we can understand that technical perspective of this plant in a bit more detail. So let's take you down and go and show you the connection of this system into the grid.
Before we go down to the inverters, quickly a look at the panels. You'll see that we've got 8 banks here, which represent an inverter every time. Every plant in itself, or array, has systems, and you can see that they are linked to strings. So each inverter has 4 to 5 strings on the panels as they are installed. For ease of installation and for ease of maintenance in future, we've numbered them 1 to 8 right through, left some spaces in between to walk, and you can see it's easy to have access to all the panels as we go. In addition, we've got the conduits or the trunking running at above every site, collecting all the DC strings and feeding them back into the inverters. Okay, here we're standing next to the inverters. We've got 25 kilowatt 3-phase inverters, and for each plant that you saw on the roof, we've got 1 unit, which means we've got 8 units. The layout very similar to what you see on the roof. For each of them, you can see the 5 strings on the DC side coming in with the DC switch, important. The cable next to it is the communication, mainly for the maintenance, and then the AC cable 3-phase going out. You'll notice here that this is a flexible cable, makes it easier to work with, and a lot simpler. The whole system neatly installed on a tray. We use these cable trays which are well ventilated in order to have the heat dissipate as quickly as possible. Right at the back there you see the orange box. That is the main connector with all the isolators and circuit breakers as well as lightning protection in the system. And at the front here you see the little box is our security systems for the panels on the roof and the protection of these inverters because it's all outside. From the orange box it feeds straight into the main grid connector, the feeder below, where the transformer is, and there we've got the 250 kilowatt circuit breaker connecting the system to the local grid here.